Okay, so obviously when the receivers are O, the distance from there to there is the same, therefore, and they're leaving the slits in phase, so they're arriving in phase. There's no path difference, they're in phase. And when it gets to here, however, it's gone from being a maximum to a minimum. So it's now out of phase. So first of all, really the distance S1 to O and S2 to O it's got nothing to do with it. They don't really care. That's irrelevant. We're worried about the difference S1 to P and S2 to P. What is it about here and here that's making it be a minimum? Well, obviously, I hope you know this, is that when it's at P, this distance to here and this distance to here are out of phase, which means if this was one whole wavelength more, they'd be in phase. If it was half a wavelength longer, if this was half a wavelength more than this, they'd arrive out of phase. If it was one wavelength more, they'd arrive in phase, or two or three, or any whole number of wavelengths, they'd arrive in phase. That's why we get multiple maxima. But the minima between those are when this path difference, is half a wavelength. So basically what we want to say is the path difference S1 there minus that distance here is 0.5 lambda. Okay, so that should be C. In fact, I'd almost say that should be minus lambda, because SP1 is shorter and that one's longer, but it makes no difference really. Anyway, it's C. There you go.